Good morning, one and all. Welcome all to the final day of National Level Online Faculty Development Program on current research trends in artificial intelligence and machine learning. I welcome you all, the participants. Today, we have an eminent and experienced resource person, Dr. S. Jagannathan sir. Now, I request G1 to introduce today's resource person.
Dr. S. Jagannathan did LLB and PG diploma from KSLU. He completed Masters in Applied Mathematics from Bangalore University. He did Masters in Software Systems from Birla Institute of Technology, Pilani, India in 1992. He completed PhD in CSC from SJCE University of Mysore in India in 1998. He worked in various prestigious organizations like ISRO, Siemens, GE, Tata, IISc, IIT, APSCE, Pranvendu, PSIT, TJIT, Jain, Nagarjuna. He published 31 papers in various national and international journals and conferences. He has been granted 6 patents. He is present working as Executive R&D in AI Connect Private Limited. So we are very fortunate to have you as resource person for today's session, sir. Thank you.
Jagannathan sir, thank you sir for accepting our invitation. And now I request Jagannathan sir to take up the session. Sir, Jagannathan sir. Sir, could you please check your mic system, sir, or sound or speakers?
Good morning, madam. Now you are able to hear?
Yes, sir.
Now it's okay, madam.
Yes, sir. Yes, sir. Thank you,
Shall
sir. Yes,
shall I
sir.
start?
You can start, sir. Thank you, sir.
Good morning to all of you. Sorry for the interruption. It's a device problem. I don't need to give my introduction because already I sent my profile. Most of the participants will be knowing my background and profile. The topic I'm going to present is AI image recognition classification using convolutional neural networks. First of all, let me say what was main attraction for this topic is present day, most of the gadgets, mobile phones, they want more and more sophistication and large data is generated. People are more interested in the more visuals. Thereby, lot of image data is generated. The volume is such a big and device capacity also matters and transmission also matters and people choice also matters. So in order to meet most of the requirements, people have come up with convolutional neural networks. So we are going to discuss how it will be helpful in image recognition and classification. It's AI connected because artificial intelligence brings the more precision as well as more demands can be met, more precision. So we'll use AI techniques. The agenda is what we see, what computers see. The data in the introduction, we use the MNIST and CIFR database, handcrafted features for image classification, and we'll touch upon deep learning and architecture, CNN architectures, and the training part, experiments, transfer learning, and complex networks. So first let us talk about what we see through our eyes and what computers see or our mobiles see the data. You can see here the idea of big data. You can see the images here, lot of images. Our idea is to bring closer to the originals. So we may do the classification. The classification is we may have the patterns. It should recognize the pattern or the system has to learn and the next time it has to take care. So it is the idea of to match to the probable pattern which is very closest to the original. You can see here the cat, whatever you see here in the our through eyes and how the computers will see. I'm showing the cat because most of the neural networks and image coding techniques nowadays, it is based on biological process. So they want to make it similar to our human brain working, as well as how the animals look at, especially cat during the night. It allows so many perceptions, so many vision capabilities. So many neurons get activated in the human cat brain. Let us take the MNIST database. It has got 60,000 training examples, 10,000 test examples, and the idea is to match to the whatever handwriting it's given and give the correct digit whatever is in the test pattern. For example, in the MNIST database, which is available in the internet, it's very widely used. The height is 28 by 28, 784 pixels. How the height looks is how it's represented, it's given in the diagram. And CI for database also, we have so many pictures, nearly 50,000 training images, 10,000 test images. And we have 60,000 images, 10 classes, each is 66,000 images. So what we see through our eyes in the mobile or in the computer, the image is made up of RGB. It's red, green, blue. So whatever we see, it's not a single image, but it's made up of 3 images. Each image is in the form of matrix. We call it as a frame, or we can represent saying in a matrix type 5 by 5, 512 by 512, 1K by 1K. So, but it is 3 images RGB. So depends on the intensities, how we take our picture shot, how we generated the image. So in the computer, color images, it will be n columns, n rows, blue, green, red, and each box, small box is a pixel, single pixel. So coming to the classification, we call it as a previous deep learning. That is before convolutional neural networks came into picture. We used what is known as handcraft features, that is entropy coding, histogram matching, run length matrix. And for the morphological features, we are very concerned about shape features, roundness, etc. Coming to the deep learning, in the deep learning, we are talking about architecture, that is convolution. It consists of convolution, pooling, and fully connected layers, and successful convolutional neural network architectures. In the deep learning, very idea is we use machine learning algorithm. Our idea is to match the output to the originals. So we use what is known as artificial intelligence. And we are going to use neural network also. Before deep learning, we used to use neural network input, hidden layer, and then output layer. In the deep learning, we use more than 2 hidden layers. Each hidden layer output is interdependent on the other. One hidden layer output will be input to the other hidden layer. More the hidden layers, more will be the precision. There are other techniques also: deep learning neural network, deep Boltzmann machine, restricted Boltzmann machine, deep brief networks, deep auto encoders, recurrent neural networks, convolutional neural networks. But we are going to talk about convolutional neural networks. So convolutional neural networks, as I said, the inspiration is from the biological process. It is like our cortex, how you capture the image in the eye, how it visualizes, how each feature is identified. It's similar to biological process. As I said, convolution, the word very convolution here in the signal processing, it's intricately twisted or folded. It's a question of how we may use and how to get the result, what we wanted. So that is why the word convolutional is used. So in the convolutional neural networks, you can see here input. The input will be image. It will be made up of 3 images. It can be any dimension, n by m. It will go through convolution and we develop feature maps. Again, we do subsampling, or we can call downsampling or upsampling. Again, followed by convolution, and again subsampling. Finally, the image is reduced to very small picture. which we fed to neural network. Neural network will recognize the object, what exactly the object in the picture. How the convolution is done. So input image, we'll have a filter. Filter is a small size. It can be 3 by 3 or 2 by 2, depending on the how precision we want. And then the filter will do the dot product with the input image and the filter. And what we get is the convoluted picture. For example, here we have taken 3 by 3. In the image 3 by 3, it reduces to one single cell, that is called 4. Number is 4. And I give the formula also I given I star k xy sigma sigma kij I xi I minus x I minus 1 y j minus 1. So we get the convoluted feature. We can call it as a convoluted feature, activation map, or feature map. For example, you take a mouse. There are some curves in the structure. So we have the input image as well as the filter, and we capture the curve exactly using the required filter. And we can see so many curves. We can capture each feature by using the required filter. For example, here, right side is given so many filters we use, or we can call it as a kernel, and we capture each feature in the image. This is the convolutional neural network of the which is used on the image, which just consists of buildings, and we have got successful results. For example, here we can take the RGB image, and we pass through convolutional kernel or a filter on the 3 images. We can see here the small box, the dot product, it will come to 308 in the first one, and second one we get the 498, and third one we get 164. Finally, when you add together, the formula is given here. It will come to output minus 25. And similarly, we pass through full images and we get the results as an output. So it's that is, we are sliding the filter or kernel on the input image, which is made up of 3 images, RGB, and we collect the result in a single image. We can call it as a dimensionality reduction. So 3 images will result into one single image, and we can get the whichever feature you want, and we can call it as a decomposition, whatever you want, and we can transmit, which will consist of only smaller bytes. It will help for the bandwidth transmission also. In the convolution, after convolution, we'll use what is known as ReLU. It's an activation layer. What it does is, it will take the negative values in the kernel output. It will convert into zeros. You can use whatever you want. Tan hyperbolic you can use, or any other function you can use. It will turn all negative values into zeros. You can see here, we'll have the negative black and white. By applying the ReLU, you will get the fully white, that is non-negative value. This is the image after the ReLU. So you can use the sigmoid, as I told, whatever function you want, depending on the image and whatever feature we want. So take, for example, what we done is now convolution we have done ReLU. After that, what we use pooling layer. Pooling layer is only we are reducing the image. That is, you can apply max ruling or average ruling. So here you can see here we have 4x4 image. It gets reduced to 2x2. So this is exactly dimensionality reduction. You can see here 224 into 224 into 64 frames. It is after downsampling, you can do it. It'll get to 112 by 112, then 64. Then after applying convolution, ReLU, then pooling, it gets reduced to a smaller picture, which will be input to the neural network for identification of the object. The actual process, you can see here, a big image goes through convolution, ReLU, pooling, again convolution, ReLU, pooling, and then finally the single image, it will be flattened, which will be input to the trained neural network, which will identify the feature object. So the architecture consists of in the convolutional neural network, convolution, ReLU, pooling, and again you can see convolution, ReLU, pooling. Finally, we will get the fully connected layer. So this is the mechanism for an image. We have the convolution, ReLU, convolution, ReLU, and then we'll get the FC, that is fully connected layer. So in summary, convolution is convolution neural network consists of convolution, ReLU, pooling, and then input to the flattened layer, that is future map is flattened. It will be given as input to the neural network, which will identify the object, which are trained neural network, which will identify the feature. So we have so many models. It's called LE-Net5. One I want to share with you. This is actually come from Jan Lucen. That is in actually neural network concept all started in 1950s by Hubble and Wiesel. And then finally in 1990, first paper came out from Jan Lucen. And what he developed is called LE-Net5, which consists of input, convolution, pooling, convolution 2, that is first one convolution, pooling 1, then again convolution, pooling 2, then finally it will be given to the neural network, which will identify the future. There is another successful model, that is convolution neural network architectures. That is it's called AlexNet. Here also we have the convolution C1, C2, C3, C4, C5. Then fully connected. Again, one more fully flattened layer. Again, it will be identified by a trained neural network. Then we have another successful architecture that is called VGGNet. You can see here, I will just zoom it. It starts with 224 by 224. That is 3x3 RGB image. And it will be taken into 64 frames. That is 3 images will take up to 64. And it will be after doing downsampling, it is 112 by 112 into 128. Again, followed by 56 by 56. It will be reduced to 56 by 56. Finally, you can see here, last image will be 1 into 1000, which will be fed to the neural network, trained network, which will recognize and identify the feature. So you can see here fully what exactly it is given here. We have the convolution and ReLU, max pooling. It can be average filter or maximum value in a, you can say 2 by 2, whichever is maximum, or 3 by 3, whichever is maximum, or average of 3 by 3. Then we'll get the fully connected ReLU. Then we get the output. This is the difference between AlexNet, Alex model, and VGGNet. We can see here in the AlexNet, which is having, for example, you can see very few layers in the AlexNet. In VG16, we have 16 layers, and VG19, we have the 19 layers. I want to say here, more the number of hidden nodes, you will get the more features. So it's up to us what is the computation we have and how much precision we want and how exactly the object has to be identified. Coming to the next training, that is neural network part. We use what is known as backpropagation, and then overfitting, regression, and dropout. So the backpropagation, we use the algorithm, by a neural network algorithm. We will match the target, and then we'll propagate the errors back, and so that white matrix gets adjusted, and then it gives the exact result or very nearby result. This is the formula for the backpropagation, that is Wi minus, you can say, N dl by dw. W is the weight, Wi is the initial weight, and then N is the learning rate. Sometimes it may be overfitting. That is, it's question of how many images we train the neural network. So all the nodes may not get trained. Only very few nodes used. So with the very few nodes, you'll be able to get the desired object. So sometimes it will be, we may not use all the nodes. So it's a question of overfitting and how to regularize as well as the avoid whatever other nodes which is not participated. Coming to the experiments, it is tested on malaria recognition. You can see here how the convolution neural network is used. It has gone through C1, C2, C3, that is convolution, and then finally fully connected layer. And it's adapted by AlexNet. The results we got from the AlexNet, which is similar to the originals. What is the manual experiments we are doing it. And then this is an example feature maps captured for the malaria experiments. That is after applying convolutional neural network and the blood samples. It's a 3D output matrix. These are some of the pictures after we get the result. And again, next one is the plant recognition and the buildings, etc. We used what is known as, you can use the trained model, which is AlexNet or VGGNet you can use, and the result, it will give the very good results, and it will identify the object what we experimented. This is the architecture for the plant recognition. You can very well see here how it is started and how we are getting the full image getting identified. These are some of the examples for the plant recognition and how all features are captured. These are the pictures initially taken and how CNN worked very well. Coming to the transfer learning, you can use the models whatever is available, or you can modify for the given experiment, or for the new images to be identified. You can use the AlexNet, or you can use the other models, and we can adapt it as we require. We can even say how many convolutions required, how many hidden layers required, we can alter it. Coming to the complex networks, you can see here how the deconvolution, that is after convolution, reverse process, how you can get back completely the originals, which will be almost equal to the originals, and the image will be smaller one. You can see very small images getting expanded and exactly matches the original. It's called deconvolutional. GoogleNet also worked on this, and it has given a lot of libraries. We can use of libraries. It's available in the internet, and we can do CNN on any given set of images. I'll mention what are the tools we can use. This is the Google LENet. This is how it is done. Convolution pooling and soft matrix. That is which can be final one, which recognizes the near object. This is how the GoogleNet. We can have the 3x3 convolution, 5x5 convolution, depending on the how you want and depending on the size of the image. There is what is known as another one is RESNet. We can see here the comparison. VGG uses 19 layers, and there is another what is having 34 layer plane, and then we have the 34 residual. It's a question of how many hidden nodes and how we go through convolution and pooling, ReLU, etc. This is the complete picture, and how we can use hidden layers, budget, and then computation budget. This is about the RESNet. So initially input convolution, ReLU, convolution, batch name. So whatever filter you want, and then again you can get the output depending on the set of images. Again, it's fast region-based convolutional neural network. So it depends upon the how we use the ReLU and convolution. Some of the examples here: CNet, CResNet, etc. So it will be useful once we start the work. So that's all I want to say about convolutional neural network. We can use the tools. If you are comfortable with the MATLAB, you can use MATLAB. Or you can use Anaconda, Python. You can PyTorch. You can use KERS libraries are available. You can call in the Python program, or you can convert your MATLAB code to Python. Already tools are available. These are the useful links we have here once we start the work. So in the internet, we have the stuff, good material to start with. And then once we develop confidence, you can model it whatever way you want it. That's all I want to say. And now I am ready to answer your questions.
Sir, thank you, sir, for your valuable session, presentation, and all the things. Dear participants, if you have any queries, please unmute yourself and
Yes.
ask the queries.
Have to unmute or
Sir, they can unmute themselves, sir. They can
Oh.
unmute and they can ask questions. Thank you, sir.
Sir, what is the need of VGG net conversion compression? Excuse me, sir. Are you there? Good morning, sir.
Sir, thank you, sir. Jagannathan, sir. Sir, your voice is not audible. And I mean, it's not. Jagannathan, sir. Thank you, sir, for your wonderful session. Thank you for sparing time to take up this session. And we are very fortunate to have you as a resource person. Thank you, sir. Now, I request participants If anyone is interested, then they can give the feedback. I request any one of the participants to give the feedback for this faculty development program.
Yeah, Namrata ma'am.
Yes, madam, you can give.
Yeah, okay. Actually, from the beginning of the session, whatever the resource persons, they have delivered the messages. I mean, whatever the presentations they have given on machine learning and the neural networks, along with the deep learning, it was more informable and also valuable information. It was. And actually, as a research person, we were very eager to know about the machine learning concepts and the deep learning. This FDP program helped us a lot in order to know in detail about what actually it does. And along with that, on the third day, hands-on session was conducted, right? It was very nice, and it helped us to work on it, and we had more practical approach on machine learning. So finally, we thank the principal of GATE Institute of Technology and also HOD of Computer Science and Engineering Department for providing these wonderful sessions on all the 5 days. Thank you.
Thank you, Kirti madam, for your feedback. Now I request any other participant to give feedback.
Excuse me, sir. Good morning, sir. Thank you, sir, for giving this wonderful session. It's very informative, sir. So I got new points about neural networks. Thank you, sir.
Sir, good morning, sir. The session is very useful for me, and everyone it will be helpful for in the real world also. Thank you very much, sir.
Thank you, sir. It was a wonderful session. You gave more points about neural networks and convolution. We got many doubts cleared. Thank you, sir.
Yes, any other participants, please give your valuable feedback.
Good morning, sir. Overall, FDP program is very useful for us, and the hands-on sessions and the last day 5 session is very useful for us, and our hands-on sessions and neural networks are very good for us, and it creates a very interest to learn many and more about our neural networks. And thank you for providing this opportunity for us. Thank you, sir.
Thank you, Charan. I request any other participant to give their valuable feedback.
Good morning, sir. This is Mohandas, assistant professor. Sir, before yesterday and before one also, I got good experience about deep learning, machine learning. And today also about neural networks, I got so many factors. Very good session, sir. Very effectively. Thank you, sir.
Dear participants, please fill the feedback form and overall feedback form, which I have posted in the chat box. Now I'm going to post the assessment link within 2 minutes. I'll be opening it for 10 minutes. You have to complete that assessment, and then we'll examine your validity. Participant, just 2 minutes. Dear participants, I have posted the assessment link. Please fill that assessment, complete that assessment within 10 minutes. I'll be closing it, and finally we'll be having a vote of thanks. The time is from 11:32. I'll be stopping it by 11:42. So please complete that assessment first. This is the assessment link. Just a minute, sorry. Just a minute. I think all the links have been posted. Please fill all the feedback forms and also the assessment. Yes. Thank you all the participants for making this program a success. Now I request convener and head of the Department of Computer Science and Engineering, Dr. A. L. Srinivasulu sir, to give the vote of thanks.
Hello. Okay. Good morning to all the participants, those who attended for the 5 days online faculty development program on artificial intelligence and machine learning. And I hope you all gained knowledge on the topics that has been covered in all the 5 days of the sessions here. And regarding the vote of thanks, I would like to thank our chief guest, Dr. Shobha Bindu, Professor of Computer Science and Engineering, and in spite of his director, and in spite of his busy schedule, he acted as the chief guest for the program and gave his valuable speech. And gave his valuable speech on about the role of artificial intelligence and machine learning in today's day-to-day life here. And next, I would like to thank our managing director, Mr. G. Raghunath Reddy sir, for giving the permission to conduct this online FDP program. And at the same time, I would like to thank our correspondent, P.K. Padmavat madam, for giving all his support in doing this the program a grand success. And also our director, Madam Srimati V.K. Srivan madam, who has given a lot of support in making this online FDP program whatever the grand success here. And also, the next, I would like to thank our principal sir, who has given a permission for conducting this FDP within a short period of time, and also all the amenities that has been done for this FDP here. And I would like to thank once again the principal sir for giving this offer, for giving the permission for conducting this FDP program here. And next, I would like to thank all the coordinators, Dr. P. Namrata madam, and Mr. J. Raghunath, Mr. K. Arun Kumar, Mr. Rajia, S. Rajia, and Mohandas sir, and as well as Srinandan, and also all the non-teaching faculty members, that is the supporting staff members and non-teaching faculty members, those who have directly or indirectly supported this the online FDP program. And a special thanks to all the participants, all the faculty members of Department of CSC for attending this the workshop here. And next one, I would like to thank the student coordinators who have actively participated in all the 5 days of program here. And last, and I would like to thank all the resource persons that who has acted as in from the day 1 to day 5. And on the day 1, Mr. Lawrence Mohan Raj, he has given a speech on AI and business here. And thanks a lot for Lawrence Mohan Raj sir. Okay, and the next resource person, Mr. S. Sai Yashwantamurthy, and he has given a nice interactive session on the hands-on tuition for this artificial intelligence and programming, and the students gained a lot of knowledge on about this the Python programming, how to do the role of Python in artificial intelligence and as well as machine learning here. And another resource person, Dr. Syed Ibrahim Isbizar, and a special thanks to the sir also, who has given a nice lecture on about machine learning and deep learning approaches for network intrusion detection system, and the role of the intrusion detections in the machine learning and deep learning. Why? Because this is the major research areas in current research work here, and where the students and the MTech project students and as well as the research scholars, they can gain knowledge. They can gain knowledge on these the things here. And the last resource person, that is the today's resource person, Dr. S. Jagannathan sir, and who is actually an executive and R&D product development and AI Connected Pvt Ltd. And he has given his Okay. And finally, I would like to thank all the participants who actively participated in this, the online FDP program. And hope you wrote the assessment exam. And all the students who got pass percentage in this assessment exam will be given the certificates here. And in the next upcoming days, we are going to conduct again an online FDP on the current the trends here, and the current research trends about in NS2 relating this one here. And hope we invite all the participants for this for the next upcoming FDPs here. And also your participation is utmost needed in the next upcoming years. And thank you once again. And thanks all to the coordinators for making this a program a grand success. Thank you once again.
Thank you, sir.
Once again, thank you all participants. And I would like to thank management, principal sir, HOD sir for giving me support and giving me this opportunity to conduct this online faculty development program. See you in future in all like the sessions, in similar sessions will be conducted, and I hope you will join all these sessions and make those sessions also successful. And thank you for making this FDP successful. Thank you all for the resource persons again. Thank you. So please fill that assessment and all the feedback forms. Soon you will be getting the certificates within a week. Thank you.
Madam, sir, Jagannathan sir is there, madam?
Sir,
I think no, sir. Yes, sir, he is there.
Madam, sir is there, madam, in the meeting?
Yes, sir.
Sir, good morning, sir. Jagannathan, sir. Hello. I think sir has unmuted.
Sir, I think he is in some other work, sir. I just called, but he didn't lift it.
Okay, no, madam, no problem. Thank you.
Thank you all participants. Let us meet again in another program. Thank you.